Hello, sir. We are Group 47, and we would like to start our presentation. So here are all our group member names and IDs. So next slide. So for introduction, for the background, this project is to focus the expansion of Permata University to Johor Bahru. The main challenge of expanding is to route the networking at the new campus in Johor Bahru so that it integrates with the Cyberjaya campus that hosts all the services. Our main objective is to design a scalable and secure network architecture while also ensuring reliable and secure communications between the two campuses. We provide the secured wired and wireless access for all users by enforcing role-based access control. So next slide. So as Sir can see, this is our network architecture design. On the left is the main Cyberjaya campus, while on the right is the Johor Bahru campus. In the middle, there are 4 routers that act as ISP, and the red dot in the middle, red dot in the middle is the outside users that will try to connect between the two campuses. Okay, so next slide. So for our implementation, we implement a 3-tier hierarchical model, which consists of access, distribution, and core layer. Access is the entry point for laptops and other end user devices to connect to the network, while distribution is the one that links between all the VLAN subnets. The core layer is the one that transports between the distribution switches, linking to the firewalls and routers that handle inter-campus and internet traffic. So for the server placement, we have 2, which is the DMZ servers, which are on VLAN 100 that hosts web, email, and DNS, as well as internal infrastructure servers on VLAN 110 that host Radius, DHCP, and syslog. So next slide. So we do OSPF for our dynamic routing. It does automatic route sharing so that the routing information, so it does the sharing of routing information among all core routers, firewalls, and layer 3 switches. And also it does seamless connectivity. Other than that, we have wireless LAN controllers that manage the wireless network by mapping the different SSIDs to different user groups. And also we implemented IPsec VPN tunnel for inter-campus connectivity. So next slide. So our IP addressing is based on the VLAN number. So take for example the internal infrastructure. So internal cyber has a VLAN of 110, and it has the IP address of 10.10.110.0. If we look at internal Johor, the VLAN is 111, and the IP address is 10.10.111.0. This pattern continues on between the administrative staff and academic network. So next, I'll pass on to the next person.
Okay, hello sir. I am the network security analyst for this team. Okay, so basically our threat modeling approach uses the STRIKE framework, which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. We basically apply this framework across all of our critical network components, from inter-campus links to our wireless infrastructure, to get a comprehensive view on it. Next slide. So based on our analysis, we've identified a few threats. The first one would be unauthorized network access. This basically refers to attempts by unauthenticated users or devices to gain entry to our network, particularly targeting VLAN endpoints and our wireless LAN controller. And the next one would be compromised public server. This basically involves attacks on our public-facing servers in the DMZ, such as web, FTP, or email servers, potentially leading to the data tampering or disclosure. And this poses a high risk. And the next one will be VPN, brute force attack. Attackers might try to guess VPN credentials repeatedly to gain unauthorized remote access, which could lead to denial of service or unauthorized entry. This is also a high risk threat. And then next one will be data sniffing over VLAN. This threat basically involves intercepting unencrypted or weakly encrypted data transmitted over our wireless network, leading to information disclosure. This is a high risk also due to sensitivity of university data. And the last one will be malware infection via email. The malicious software delivered through email could lead to system compromise, data theft, or even elevation of privileges on user endpoints and the email server itself, presenting a high risk as well. Okay, next slide. So the security countermeasure and compliance, basically, to counter this risk, we basically implemented a layer defense, and the key measures include robust firewalls and access control lists to segment traffic, an intrusion prevention system or an IPS for real-time threat blocking, and AO2.1x with radius for secure authentication across both wired and wireless networks. And then we also deployed a secure IPsec VPN and multi-factor authentication for inter-campus communication, alongside network segmentation via VLAN and hardening of our DMZ. And finally, we have the DNS and DHCP protection to prevent rogue servers and malicious queries. And the next countermeasure is alignment with industry standards. So our design strictly aligns with industry best practices and standards. This include ISO IEC 27001 for overall information security management, NIST like NISP SP 853 and the last one there. So okay, next slide. And for incident response and log management, we basically adopted the NIST 861 framework, covering preparation, detection, containment, and post-incident analysis. And the centralized syslog servers are crucial here because it collects logs from all critical devices with SIM integration to alert us to any anomalies. And the last one will be legal and regulatory compliance. We basically have Malaysia's PDPA and then GDPR, basically for EU students, and then we have university policies. Yeah, ensuring data privacy and protection basically is all to adhere to the university's internal IT security policies. Yeah, now I'll pass on to the next person.
All right, thank you, Ethan. So now I will walk you through the three main pillars of our secure connectivity design. So for the first one, to deliver a secure and scalable wireless access, so we must have a multi-layer to ensure that data is protected whenever it's moving between campus across the wireless network or during remote access. So for the second one, which is centralized wireless LAN control. So for this one, it provides a role-based isolation by mapping different users to distinct SSIDs like academy, guest, and admin. So which correspond directly to their assigned VLAN. So for the next one, which is the remote access control. So for all remote access control for administrators and branch campus user is secure through authenticate and encrypted communication channels, which and this ensure that no matter how a user connects, the section is secure, creating a protected and unified network environment for the entire university. So for the design, for the key implementation, so we have implemented the inter-campus VPN, which is the site-to-site IPsec VPN tunnel. So this tunnel will encrypt all the data using a strong algorithms like AES 256 to ensure confidentiality and integrity. So For the next one, which is our wireless access. So our design use a centralized VLAN controller. So we have separate SSID for academic guests and admin user, which map directly to their VLAN. So for the last one, which is our server and remote access. So for this one, we have so implement that the server are protected through segmentation. So public server service like the web server uh, are isolated in a DMZ, while internal service like DHCP and Radius are in a separate. So all remote administrative access to network device is restricted to the secure SSH protocol and controlled by access control list. So that's basically for our key implementation for secure connectivity. So in conclusion, so our project successfully deliver a comprehensive and secure network infrastructure for Pertama University. So this design meets all the key objectives for security, scalability, and high availability through the strategic segmentation, redundancy, and also robust security control. So looking forward, for our future improvement, I think we can recommend the university consider adopting the visualization for servers to improve scaling and also implement the dynamic VLAN assignment via the Radius to simplify the management, and also exploring SD-WAN technology to enhance inter-campus link redundancy, and also AI-based monitoring tools for advanced threat detection. So that is basically all our presentation. Thank you.